Hello everyone, my name is Komal and today I am going to explain you the topic limits. So, what is limit? Limit means to set bounds, to restrict. It is the study of calculus, it is the branch. So, now we will study the definition of the limit. So, limit is the value that a function approaches as the input approaches some value. So, we can find the value of the limit by studying the graph or the nature of the function around x equals to a. So, now we will study the limit by the help of the graph. Let's draw the graph here. So, this is our xy plane. Let's take a random curve y equals to fx. Now we will study the neighborhood x equals to a. So, at x equals to a, we have the point on the curve, but we will study the neighborhood. As x equals to a has two neighborhoods, x equals to a plus h and x equals to a minus h. A can be approached from two sides, so where h is greater than 0. Now let's check the value of y. We can write a plus h as a plus, and here we have the point a minus f a minus. So we will study the neighborhood of x equals to a. As x equals to a can be approached from two sides, left hand side and right hand side. So limits, it is of two types, right hand limit and left hand limit. So we will now study the definition of right hand limit and left hand limit mathematically. Since x can be approached from two sides, that is right hand side and left hand side, so we have two neighborhoods, right neighborhood and left neighborhood. Let's see, we draw the real line here at x equals to 2. This neighborhood at 2.0001 will be called the right neighborhood, and the left neighborhood where x will be approaching to 2, that is 1.999, we have the left neighborhood. Since we have the two neighborhoods, left neighborhood and right neighborhood, so we have two type of limits, that are left hand limit and right hand limit. So mathematically we can write limit. Limit is, in the short form, it is written as lim, x tending to a fx, but we are approaching from the left hand side, so we write as f a minus h, where h is greater than 0. So limit, we find its value. Since x we already here approach to a where h tends to 0, we can write as h tends to 0. This can be written as f of a minus. This is the mathematical definition of left hand limit, the value of LHL, that is f of a minus. In the right hand limit we have limit h approaches to 0, f of a plus h, where the limit is approached from the right hand side. We can write here as 2 plus h and 2 minus h. So by calculating the value, we write as f of a plus h. So since h is tending to 0, so it tends to f, but we write as a plus because a is greater than, the value is greater than a. So we write as f of a plus. Now here is LHL and here is RHL. Now for the existence of limit, we have the two values same. So for the existence of limit, we have LHL equal to RHL. This is the basic definition for the existence of limit. That is, left hand side limit is equals to right hand side. So, and for the most important thing is that it should be finite. If it tends to infinity, then we say limit does not exist. So both should be equal to some constant L which is finite. That is, the behavior of the function in the left neighborhood and the right neighborhood remains same. So this is all about the left hand limit and right hand limit. Now we check some examples which are limit x tending to 3 x square minus 9 upon x minus 3 tends to what? We have to calculate as x approaches to 3 what will be the function. This x square minus 9 upon x minus 3 will be tending to what? Here the domain is given R whole of the real line but not defined at x equal to 3 as the function f3 is not, fx is not defined at x equal to 3. So we have the domain R minus 3. So as we can see that f3 is not defined. So we check the neighborhood of x equals to 3. That is, we check where x is not equal to 3 but around we check the limit. So we calculate here as fx can be written as by factorizing x square minus 9 we write x minus 3 into x plus 3 upon x minus 3. We will be checking the limit as x tending to 3. What will be the fx approaching? So we write here limit x tends to 3 in x minus 3 upon x plus 3 upon x minus 3. As we do not directly put x equals to 3, we put in the neighborhood, we check in the neighborhood. So as x approaches to 3, let's check in the right neighborhood at 3.00001. X minus 3 and x minus 3 both will be becoming what? At x equals to 3.00001. So it will be approaching to very small number 0.1. But it is non-zero. It is here, it is also non-zero, and same it here also it is non-zero. So we can cancel non-zero terms. We cannot cancel 0 by 0, but we can cancel non-zero terms. So here we can cancel out these both terms. So the next step is very basic. X tends to 3, what will be x plus 3 tending to? This becomes whole of the number 6. This is called the limit of the function. In the right hand limit and in the left hand limit, both they will be approaching to 6. They are both equal, so we say the limit exists and it equals to 6. Now we check out More example, that is what will be the fx tending to as x approaches to 2. Domain is written here, x is not equal to 2 because at x equal to 2 the function will not be defined. So we check in the neighborhood of 2, that we check here, this is the real line, what will be the curve tending to, what will be the value around x equals to 2. So we calculate here, the modulus function is given, as the modulus function is continuous, but we will check both the right hand limit and left hand limit separately. Now we first calculate left hand limit as x approaches to 2 minus. What does 2 minus mean? That we are approaching the function from x from the left hand side, that is 2 minus. There it will be 2 minus and here it will be 2 plus. What will be the function tending to? Now at x, as x approaches to 2 minus, we write here fx. So putting the value of fx, we get as h tending to 0, f of a minus h, that is we write here we put a minus h, that is 2 minus h minus 2 upon 2 minus h minus 2. Here we will be checking what will this value, whole value approaches as h approaches to 0. So we further calculate it, we get modulus of minus h upon minus h, as the modulus of the negative number is equal to the positive of that number. So we write h upon minus h, which is equals to minus 1. This is the value of LHL. Now we calculate the value of RHL. So for RHL we have limit fx, x approaches to 2 plus. Now we are approaching the function from the right hand side. We write here limit f of a plus h as h tending to 0. So here we find, by putting the value of fx, we get here x 2 plus h limit h tending to 0, 2 plus h minus 2 upon 2 plus h minus 2. Calculating it further, we get modulus of h upon h, which cancel out as h is a positive number, where h is a positive number. So the modulus of positive h is at h itself. So h upon h, we get RHL equals to 1. Now we can clearly see that LHL is not equal to RHL, so the limit does not exist. Here LHL is not equals to RHL. In this case we say that limit does not exist. This is all about the existence of the limit. Now we see the indeterminate forms. What are indeterminate forms? As the name suggests, whose value cannot be directly calculated by substituting the value of x. So we solve here the indeterminate form. Now there are total 7 indeterminate forms. These are 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 1 power infinity, 0 power 0 and infinity power 0. So what are these number means? 0 by infinity. It does not mean 0 or infinity. It is that there are limiting 0. That is, the x tends to 0, not equals to 0. That is, x tends to 0, but x is not equals to 0. In all the numbers written here, they are not numbers. They are the value of the x which it tends to. So, one more thing that we usually write here 0 power infinity. So, one can say that it is also indeterminate form, that we cannot calculate 0 power infinity, but this is not indeterminate form because its value actually tends to 0, because when very small numbers are multiplied and so on, we multiply very small numbers, it actually gives us 0. So it is not indeterminate form. Now we study that why we need indeterminate form. Let's take an example. Fx equals to x minus 1 upon x minus 1. Now one can say, why don't you write it equals to 1? But this is not, we are checking about around the neighborhood of x equals to 1. That is, we check the graph of the function. Around x equals to 1 we have, when x is greater than 1, we can simply write here y is equals to 1. So, and at x equals to 1, the function is not defined. So, by checking when x is less than 1, we get y equals to 1. But there is a hole in it. At x equals to 1, the function is not defined, so we draw the graph like this. So, when we write that when x approaches to 1, we have 0 by 0 form, as x minus 1 also tends to 0 and the denominator also tends to 0. So we write here 0 by 0 form. Now we study 0 by 0 form. That is, to solve the 0 by 0 form, we factorize, rationalize or double rationalize in order to get rid of indeterminacy. That is, when the function is given, we rationalize or double rationalize. Let's check out this example. Limit x tending to 1, x cube minus 1 upon x cube plus x minus 2. So, in this case, we factorize. We get, as x minus 1 is common in both. So, we get here x minus 1, x square minus x. So, we write here plus x plus 1 upon x cube minus 1. Minus 2 can be written as minus 1 minus 1. So, x minus 1. Here, x minus 1 is common. So, x minus 1 into x square plus x plus 1 upon x minus 1. Here, x square plus x plus 1, and it is also common. So, we write here plus 1. Now, as limit x tending to 1, it is not equals to 0. It is tending to 0. We can cancel non-zero terms here. So, by cancelling the non-zero terms here, we get here, as now we can directly substitute the value of x. So, we get here 1 plus 1 here, and in the denominator we get 1 plus 2. So, the value of function as x approaches to 1 is 3 by 4. In this case, we factorize. Now, let's check one more example. That is, limit x tending to 0. What will be the function approaching? X under root 5 plus x minus under root 5 minus x. In this case, we rationalize. Now, x upon under root 5 plus x minus f 5 minus x into now we rationalize here, multiplying both its conjugate we are multiplying. By solving further, in the denominator we get, as they both are a minus b into a plus b, we know the formula a square minus b square. So we can write here 5 plus x minus 5 minus x. So solving further we get x into under root 5 plus x plus under root 5 minus x upon what we get in denominator 2x. Now taking the limit x tends to 0. So what will be the limit as x tends to 0? As we can cancel the non-zero term here. So now putting x equals to 0 directly here, we get under root 5 plus under root 5 upon 2. That is 2 root 5 upon 2. We get here the limit of the function as under root 5.